Hello everyone, my name is Derek,
My name is Vincent.
and today we are from class 12D and we're going to do our math assignment exams.
So in this video we're going to explain about three materials. So the first material is transforming two-dimensional shapes using matrix multiplication. The second one is solving problems regarding the maximum point of quadratic function, and the last one is determining the surface area between a curve and a straight line using the concept of definite integrals.
Okay, enjoy!
In this first part, I will be explaining about the 10th grade material, which is transforming a two-dimensional shape using a multiplication with matrix. So 2D shapes consist of several points that is written as x, y, and to transform the shape, we need to transform each of the points individually by using the transformation matrix. The transformation matrix is this A, B, C, D, and the formula that we'll be using is this xy action, where it's equal to the transformation matrix multiplied by the point, resulting in A multiplied by x plus B multiplied by y and C multiplied by x plus D multiplied by y. So now we'll be explaining about the example question where a shape consists of 4 points A, B, C, D with coordinates that can be seen here, and they will be transformed with the matrix 2, -1, 0, and -1. So we are told to find the new coordinates, so we can just simply use the formula x action, y action equal to the matrix of transformation A, B, C, D multiplied by each coordinates. So to find the first point A action, we can just simply input the matrix inside, multiplied by its coordinate 3, 1. As a result, 2 multiplied by 3 is 6, added by -1 times 1 equals to 1, it will be 5, and 0 times 3, 0, -1 times 1, -1. So the point of A action is 5, 1. And to find all of the others, we just simply do the same steps again. So this is all of the coordinates that we got from the transformation. So to conclude from this, we can know that matrix multiplication can be used to transform the geometric shapes, and by multiplying each point with the matrix, we can find the new position of the original coordinate, where in this example, point A, B, C, D will be transformed to A action, B action, C action, and D action. This shows that the matrix can affect the position and the orientation of the shapes.
So I'm going to explain you all about the second chapter, which is about the quadratic functions and how to find the maximum point through that function. So that function has a lot of basic formula. One of it is ax squared plus bx plus c equal to 0. Now, from this, we need to convert that basic formula into y equal a times x minus h squared plus k. Now, after we convert this, the basic formula into that formula, we can then find the maximum point, which is h comma k. Now, after we find this, we can also conclude that actually the fast way to find the maximum point of k of x is by through a really simple formula, which is x equal minus b per 2a. Hello all, so I'm going to give you an example regarding how to find the maximum point in a quadratic function. So given that this is the quadratic function and we need to find the maximum point of this function, so firstly we need to know the value of a. So the value of a is -2, and then we can just convert this into this formula, the square formula I call this, and then because the a is -2, so it's going to be -2. And how to find the h? So how to find the h is 4 divided by a equal -2, and then we divide it by 2 again. So -2 divided by 2 is equal -1, and here we go, and then plus k. And it's going to be +1, and because we didn't need this constant, this value, so we need to reduce that. So 1 times -2 is -2. In order to make it 0, so we need to add another 2. So -2 x minus 1 square plus 3. So after we already find this, we already know what is the maximum point. The maximum point is going to be 1,3. Now, so to conclude things up, when you want to find the maximum point of the quadratic function, we need to convert this formula into this, and then we need to find the value of h and k in order to get the maximum point. But however, there's a faster way to do it. You can just make this formula over here, x equal minus b per 2a, where we can find the maximum point of x in this quadratic function easily. I think that's all. Thank you.
So now I will be explaining the third part, which is the 12th grade material. In this part, I will explain how to find the area bounded by a curve and a straight line using definite integrals. So the definite integrals is written by this formula, which calculates the area under the curve from point x equal to a to x equal to b. And then the second formula is the area formula for between two graphs, which is this formula. So to find the area between two graphs, we subtract the function that is lower with the upper function, then we integrate. So there will be two conditions, where in the first condition, if the line is above the curve, then we will do this by subtracting the line function with the curve function. Secondly, if the curve is located in the upper area above the line, then we subtract the curve with the line.
So hello everyone, so I'm going to explain to you all about how to find the area between the line and curve. So firstly, we need to determine what is above them. It is the line or the curve. In this scenario, we already see that the line is above the curve, but because it is in the negative side, so the formula is going to be a little bit different. Because in the negative, so it's going to be negative, and then BA, and then curve minus line. So it's going to be the opposite, not line minus curve, but curve minus line. And then we just put it in the formula. So the intersection point is 3 and 2, the curve is going to be x squared minus 6x plus 5, and then plus 6 plus x plus 1 dx, and then square minus, and then I'm just going to integrate it and put the negative, so it's going to be easier. Okay, and then because there's no space left, so I'm going to put it over here. I'm sorry. So 2 minus 8 per 3 minus 2. So minus 27 plus 2 plus 45 per 2 plus 8 per 3. It's going to be minus 25 plus 156, so it's going to be equal 1 per 6 units square. Okay, I think the answer is going to is 1 per 6 units square of this problem. So to conclude things up, or to sum things up, when we want to find the area between line and curve, first we need to determine what is the buff bit. Is it the line or the curve? And then we need also to determine, is it in the positive side or in the negative side. And in this scenario, it is in the negative side, so it's going to be the opposite. So it's curve minus line dx. Now, and then we just find it, and then we just input the intersection points that we already know, and we just minus it and integrate it, and finally we got 1 per 6 units square. I think that's all. Bye bye.
Easy go.